Time is the relentless adversary in solving critical national and global problems. And high-performance computing, HPC, is the powerful tool that challenges that adversary using computational simulation. HPC-driven computational modeling allows researchers to solve problems that have proven insoluble by traditional means, whether they're too hazardous to study in the laboratory, time-consuming, or expensive. HPC, with the power of massively parallel processing, provides the capability to build complex models of urgent real-world scenarios and run them millions of times with different what-if variables. That's what happened when Sandia played a key role in responding to the Ebola crisis in West Africa. The power of HPC modeling and simulation, coupled with verification and validation, resulted in the development of an optimized blood sample transportation network to provide safe, efficient, and timely Ebola diagnoses.
What we did was run the model millions and millions of times using a wide variety of different inputs to represent the different actions that people could be taking on the ground in Africa. We were able to come up with rock-solid recommendations to the international community that resulted in a new sample transport optimized network, which then increased the ability of the team to be able to control the disease going forward.
Sandia's modeling results were immediately implemented by the Center for Disease Control and Prevention, the World Health Organization, and the 101st Airborne Division as strategies to dramatically improve Ebola diagnosis time. These optimized routes and models are still in daily use 2 years later. Sandia's HPC models help define national pandemic policy. The Ebola crisis was just one of many complex, time-critical challenges tackled by Sandia's HPC. And there's a lot that goes on behind the scenes to accomplish the Ebola response and other critical, real-world problem-solving operations. It requires teams of people working in computer hardware, storage, networking, operating systems, file systems, and user support. With over 1,500 users across 5 security environments, the 30 members of the HPC team are responsible for the procurement, deployment, operations, and decommissioning of Sandia's HPC systems and supporting infrastructure.
So I have the unique and challenging opportunity to work with a team of high-performance supercomputing engineers. We integrate the hardware and software into unified engineered systems, which are then deployed across 15,000 plus servers.
We're always on some cadence for improvement. We're always trying to make the environment better for our users.
The HPC Operations Support Team is responsible for monitoring all of the thousands and thousands of nodes of the HPC Capacity Cluster System. We also provide support for user questions. We do that in conjunction with the HPC Help Desk.
The collaborative efforts and expertise of all the HPC teams helped enable the prestigious R&D 100 Award for research that could prove transformational in efforts to control global climate change. In the race to solve the nation's most complex scientific and engineering challenges, Sandia's high-performance computing capabilities are a critical resource to researchers as the platform for new discoveries and innovation.